Hi everyone and welcome back to my channel A in Economist. So this is going to be our 6th lecture on time series analysis and forecasting playlist, where if you have followed my playlist you will know that I have covered some important covariance stationary processes. Particularly I have talked about what is a white noise process, and then I have talked about MA process, that is the moving average process of different orders. Particularly I have covered moving average process of order 1, moving average process of order Q, and moving average process of order infinity, right? So this is what we have covered till now. Today we will move a little further and learn about the auto-regressive processes, right? Auto-regressive process, or which is also known as the AR process. So let's start with that. What is auto-regressive process? So if you have seen my videos, you will know I have talked about MA process, where I told you that MA process will be a function of epsilon t and the lag values of epsilon t's, right? This is what I have told you as a thumb rule. I told you to remember that in case of MA process of any order you can consider, MA process will always be a function of epsilon t's and some lag values of epsilon t's, right? But in case of auto-regressive process, from the name you can understand auto means self, right? The word auto means self. So in case of auto-regressive process, what will happen? The process will be a function of only the lagged value of that process itself, that dependent value itself. So if you consider yt is the dependent variable, so yt will be some function of the lag values of yt's only, where h is not equals to 0. I hope this is absolutely clear. It's very simple. Auto-regressive means the dependent variable is being regressed on some of its own lag values, right? Some of its own lag values, and hence the name is auto-regressive. You are regressing yt on its own lag values of some yt. So it can be yt minus 1, yt minus 2, so on and so forth. That we will come to know, right? Up till this much, I hope it is clear. Now, in this lecture, what we will do, we will consider what is auto-regressive process of order 1, and in the next few lectures we will be covering what is auto-regressive process in the general form P, right? This is the analysis will be the exactly same what I have done in case of the moving average process, only again we will be differing the orders, and we will see one by one what is auto-regressive process of order 1 and what is auto-regressive process of order P, right? So let's start with this. Let us tackle auto-regressive process of order 1 in this video. So a time series process yt is said to follow an AR1 process if it can be written as, let us see the general form. Yt will be written as this: alpha plus phi yt minus 1, right? Yt minus 1 plus some epsilon t, where this epsilon t should follow white noise 0 sigma square. Not only that, where this alpha and phi are some constants. Alpha and phi are some constants. So let us see what I have written here. I have written that yt has to be in this particular format in order to form the AR1 process. So AR1, from the name itself you understand the degree is 1, means the maximum lag value is 1. If you haven't watched my MA process videos, then I'll give the link in the description. You can watch that first, because there I have explained all the concepts, how this degree comes from. So this degree is basically the maximum lag value, right? There I have described in details that this degree represents the maximum lag value that this process has. So here you can see yt is a function of only its own lag value yt minus 1 in the previous period lag value, right? Immediate lag value, and hence it is AR1 process. The maximum lag value is 1, right? And this epsilon t as usual follows white noise, 0 sigma square, and this alpha and phi are some constants. Now this representation, this is the first way of representing AR1 process, and this representation is known as AR1 process. This is called AR1 process with drift. AR1 process with drift. What is the drift? If this, this term, this intercept term is present in your AR model, then we will say that this AR1 process is with drift. The drifting parameter is alpha here. But there could be a second representation of AR1. What is that second representation? Here you only remove the intercept term and only write in this way, right? And everything else is the same. Epsilon t follows white noise, 0 sigma square, and again, and this phi is a constant or a scalar, whatever you want to call it, right? So this is the second representation or another representation of AR1 process, and this AR1 process is without drift, right? This is AR1 process without drift. I hope this is clear. There is no intercept term here, but if you want to represent it in the entire form, then intercept term and slope term both will be present, right? This is the AR1 process with drift, and there is no intercept term, so it is without drift. Now, what is the difference between these two? If you want to understand this, I have given you this graph. It will make your concepts more clear. Let's see what this graph tells us. So here in this x-axis you have the time, right? In this axis you are measuring the time, and in this axis you are measuring the dependent variable yt, right? This is yt. Now what will happen if you consider the model with drift? Here you see there are both the slope and the intercept term are present, right? So the model is this. This is the first representation I have told you, and as of now assume that mod phi is greater than 1. Now mod phi is greater than 1 has a very important significance that we will show you when I'll be describing the stationarity of the AR process. But as of now, understand when the mod phi is greater than 1, the process will look like this. So here you see the mean value or the average value of this process is varying with time, right? As the time increases, the mean successively increases, right? The second thing is that you can see the variance also increases with time. So initially the variance was low, but as and when time goes by, the variance also increases. So mean and the variance both dependent on the time. Also the auto covariance, if you see, that will also be dependent on time. So it is clearly a non-stationary process. Not only that, it has a particular slope. It has an upward rising slope, right? So this will be somewhat the diagrammatic representation of the first representation that I have told you for AR1 process, which has both the intercept term and the slope term diagrammatically. But what will happen when you consider the second representation? If you eliminate the intercept term and have only the slope term, this will be somewhat the diagram, where what you see is that the mean is like this, right? Mean is not varying over time, right? I hope this you can see clearly. Mean is not changing, but the variance is dependent on time, right? Variance is as usual. What you have seen here also variance is dependent, here also variance dependent. As the time increases, the variance also increases, right? So if you draw like this, you can see as the time increases, this gap increases, right? This gap increases means variance increases, right? So here the mean is not dependent since we have eliminated the intercept term, but the variance is still dependent on time. So that is the effect of taking the model without drift. If you consider the model without drift, the mean will be independent of time, but if you consider this, mean will be a function of time, right? I hope this is clear, and this is the difference between these two representations that I have talked about, right? Okay. So the next important question that we need to answer is that what will be the restrictions on this alpha and phi so that the process is stationary. So again, when we analyze any process, we consider two broad things: whether the process is stationary or not. This is our first, area of focus, and the second area is what are the characteristics, that is what is the expected value, what is the variance, and what is the autocovariance, right? So these are the two basic focus that we want to talk about, and we have done this previously also. If you have seen my videos, you will know we do this systematically. Okay, now here also AR1 process, we need to find out what are the restrictions on the parameters alpha and phi so that the process is stationary. So let us do that. So this is the process, this is the first representation, and I'll be using this only henceforth, right? You can, for your convenience, you can do the entire exercise with the second representation. The results will be almost the same. So let's see how we do this. Alpha plus phi. Now I'll write this as the lag of yt. This again I have told you earlier if you don't know. Yt minus 1 is simply lag of yt. Now you can take this to the left hand side. Phi Lyt is simply alpha plus epsilon t. Then take yt common. You will have 1 minus phi L is alpha plus epsilon t. Now what we can write from here is that this entire thing, this is a function of only L, right? Phi is a constant, 1 is a scalar. So it is, this entire thing is a function of only L. We write it as capital phi L, then yt is as it is, and then here you have alpha plus epsilon t as it is, right? I hope this is clear. So here what is phi L? Phi L is 1 minus capital phi L. This is capital phi. Capital phi L is a function of, this is a linear function 1 minus phi L, right? Now what is this phi L? Where this phi L is, as I have told you, 1 minus phi L is called the characteristic polynomial of AR1 process. Now again, this is the same thing that I have told you in case of MA1 process also. In case of MA process, you have written it as the capital theta L, if you remember. I'll give the link of the video in the description. Please go and watch this first. So in case of MA process also, I have told you this is the characteristic phi L. This is capital theta L. In case of MA process, you write it as capital theta L, which I have told you is the characteristic polynomial of MA process. And here you have capital phi L. Phi L is here. In case of AR1 process, this is like this. This is the characteristic polynomial. Now the most crucial part why we do this is this. What is the condition for stationarity? I want you to understand this very well, because all the questions that you will be solving will be dependent on this only. That if phi z equals to 0, this is capital phi z is 0, has all the roots lie outside the unit circle, then we will say AR1 process is stationary. Now understand what I mean by this. This is a function of L, right? Phi L. But L is not a variable. L is an operator. We call this as the lag operator, right? L is an operator. So you cannot find the root if you write in terms of operator. So operator cannot have a root. Only a variable can have a root, right? Only a variable can have a root. Operator cannot have any roots. So whenever we talk in terms of the roots of the equation, whenever we talk about the roots of the equation, you must consider, you must replace the lag operator in terms of some variable, and that is what we have done here. L is replaced by z. Z is some variable, right? Z is some variable. It is not an operator. So since we are talking about roots, only a variable can have a root. Hence we replace this L by z, some variable z, and we equate it to 0. So here what I am saying is that here phi z equals to 0. Capital phi z equals to 0 means what? 1 minus phi z equals to 0. Simply this, right? 1 minus, here you have phi L. So replace L by z. So 1 minus phi z equals to 0. So this is the equation that we are talking about. Now we are saying that if the roots of this equation lie outside the unit circle, then the AR1 process will be stationary. What is unit circle? Unit circle is simply a circle which has a radius of 1 unit. So we are saying if the root that you will get from here you will have only one root, right? You can see this from here. So the root that you will find out, if the mod value of that root lies outside the unit circle, lies somewhere here, lies somewhere here, lies somewhere here, it does not lie within this circle, right? If it does not lie within this circle, means that it lies outside the unit circle, then only you will say the AR1 process will be stationary. I hope this is clear, but if you have any doubt, you can let me know in the comment section. I'll be replying to that. So what I am saying here is that find out, firstly replace this lag operator with some variable, since we are concerned with the value of the root. And once you get the root, check that if the mod value of the root, sometimes you will get the root as the negative value, so take the mod value of that, and if you see that mod value is strictly greater than 1, which means that the root lies outside the unit circle. Unit circle means a circle which has a radius of 1, then you will say the process is stationary, right? And that is exactly what I have done here. You can see this, that phi L is this, I have equated it to 0, then what you get, z is this, and this is the only root of phi z equals to 0. Why this is the only root? Because this is a linear equation, right? Linear equation has only one root, so this is the only root, 1 upon phi. Now same thing, mod z is greater than 1, so this root is greater than 1 by mod phi greater than 1, which will give you this, and this is the most important thing. This is the most important thing in case of AR1 process. In case of AR1 process, when mod phi is less than 1, whenever mod phi is less than 1, the process will be stationary. And that is why I have told you while showing you this diagram that this has some special significance. When mod phi is greater than 1, the process is non-stationary. What we have visually also seen earlier, that the mean and the variance is varying with time. Here the variance is varying with time, so which means that the process is non-stationary. And this slope term phi is only responsible for checking this stationarity. The intercept term does not hold any value. There is no restriction in the value of alpha, only the value of phi matters, right? So we started with the question that what should be the restrictions of alpha and phi so that the process is stationary. So we'll say alpha does not have any sort of restrictions. Alpha does not have any sort of restrictions. The only restriction will be on phi. If the mod value of phi is less than 1, we will call that the process is stationary. If it is greater than equals to 1, we will call that the process is non-stationary, right? If the mod phi is less than 1, the process is stationary. What we have found out here, this criteria. But if it is greater than or equals to 1, the process will be non-stationary. And that is what I have written here, summarized here, that mod phi less than 1 is the stationarity criteria for the AR1 process, and if mod phi greater than equals to 1, there does not exist a covariant stationary process with a finite variance, which basically means what we have again diagrammatically seen, that if mod phi is greater than equals to 1, the variance of yt tends to infinity as t tends to infinity. Again the same thing from the diagram, as t tends to infinity, the variance explodes, right? Started with a small value and then it sort of explodes. So as t goes to infinity, the variance will go to infinity. I hope you find this video helpful. If you do, give me a like and do subscribe to this channel AN Economist. And in the next video, I'll be continuing with this AR1 process, and we will see how we can convert this AR process into an MA infinity process, and then we will go into the mean variance and auto covariance function of this AR1 process. So stay tuned, and thank you for your time.